All right, let's just dive right in. Today, we're talking about that moment. The one where the magic of Kubernetes just kind of collides with cold, hard reality. You know, what happens when this platform that feels totally infinite suddenly smacks right into a wall? And this quote, man, it just sets the stage perfectly, doesn't it? It totally captures that feeling when an engineer realizes the system they've been relying on, this super robust thing, is starting to feel, well, fragile. And that's really where our story kicks off. So what do we even mean by fragile? I mean, it's not like you're getting loud failures or big, scary error messages all over the place. Nope. It's more of a subtle, kind of unnerving feeling. That sense that the abstraction you put all your trust in is starting to buckle under its own weight. And you know what? When engineers hit this wall, the conversation almost always turns to one specific component, etcd. Suddenly, etcd becomes the face of the entire problem. But here's the thing. This isn't a story about a broken piece of software. It's really about our own expectations just crashing headfirst into the system's actual intended design. This right here, this gets to the very heart of the promise of Kubernetes, right? To hide all the messy complexity. You're not supposed to have to think about the database. You're not supposed to worry about how state is stored. And for a long, long time, you don't. etcd is just there, in the background, quietly holding the whole show together. Until, all of a sudden, it's the only thing you can think about. Okay, so let's properly meet the component at the center of all this drama. Because to really get a handle on the problem, we first have to understand what etcd was built for. And maybe more importantly, what it wasn't built for. So what is etcd? Well, a good way to think about it is like the central nervous system for Kubernetes. It's the key value store, the database, that holds the desired state of your entire cluster. Its whole job, its entire reason for being, is to be a super, super reliable source of truth. Its entire design is optimized for one thing above all else: consistency, making sure everyone agrees on what the state is. And this illustrates the core trade-off perfectly. etcd was built for consistency. It was not built for just raw, massive throughput. That's a classic fundamental engineering trade-off. And you know what? It works beautifully, right up until the point your scale starts demanding something the system was never designed to deliver. Now, this part is absolutely crucial. etcd isn't operating in a vacuum here. It's locked in this constant high-traffic dance with the Kubernetes API server. Every single pod you create, every service you update, it's all a transaction that hits etcd. Just try to imagine a huge CI/CD system spinning up and tearing down thousands of pods a minute. You're not just scaling a database in isolation, you're trying to scale a database that's getting absolutely hammered by the busiest part of the entire system. Which brings us to this quote. It's really just the default path running out of road. And that's the key takeaway, isn't it? When etcd starts to struggle, it doesn't actually mean something has failed. It just means, well, you've hit the end of the line for the standard out-of-the-box setup. You've driven that default configuration as far as it was ever meant to go. And all of this, it all builds up to a pretty uncomfortable, but also kind of liberating truth. The problem isn't what we think it is. It's not the tool. It's the architecture. So, of course, this leads to the big question. Is etcd broken? I mean, this is the question everyone asks, usually when they're super frustrated. Your control plane is slowing to a crawl, deployments are timing out. It just feels like something has to be fundamentally broken, right? The answer? No. Your assumptions are. The tool is doing exactly what it was designed to do. What's actually broken is our assumption that it would just scale forever. The belief that that magic abstraction was a perfect shield that would never crack. You know, for a lot of engineers, hearing this is a massive relief. It's like, okay, it's not just me. It validates the struggle. It's not a personal failure. It's a known, predictable rite of passage when you hit a certain scale. It becomes this shared battle scar. Someone will say, this guy etcd, and you'll know exactly what they mean. It's a sign you're operating in the big leagues. And most importantly, it signals a huge turning point. Stop trying to fix the component and start rethinking the entire architecture. But, and this is the harder pill to swallow, there's no easy fix. You can't just go and swap out the component. There's no apt-get install bigger etcd. The solution isn't a simple replacement part. It means you have to fundamentally change your design. You have to change your entire approach to how you're using Kubernetes. Once you accept this truth, though, the whole conversation shifts.
It becomes less about putting out fires and more like architecture as therapy. You're not looking for a quick fix. You're trading one set of problems for another, and you're doing it on purpose.
And here you can see the main paths forward. And the first thing you'll notice is there's no silver bullet, not a single one. You could shard your data, right? Split your resources across different etcd instances, great for scale, but now you've got more complexity and multiple sources of truth. Or you could just run a bunch of smaller clusters. That's often cleaner, but boom, now you have way more operational overhead. There are even some clever hybrid models, but they can be pretty fragile if you're not careful. See the pattern? Every solution creates a new problem.
Which is why you hear this phrase a lot, pick your poison. That sums it up perfectly. You are not finding a perfect, problem-free solution. You're making a conscious, architectural choice about which set of challenges you and your team would rather deal with.
Okay, so let's wrap this up. What's the real lesson here? What's the big takeaway from this whole journey from the home lab illusion to the hard reality of massive scale? It's this. The way Kubernetes behaves in a small, cozy environment is absolutely not how it behaves at scale. And this is so critical to get. That smooth, predictable, almost effortless experience you get in your home lab or a tiny dev cluster, it doesn't scale in a straight line. The system's whole personality changes under pressure. So what actually breaks? Well, it's not etcd. It's not even Kubernetes, really. What breaks, what shatters, are our assumptions. The assumption that the defaults will scale forever. The assumption that a good abstraction means you can just completely ignore what's happening underneath. And the assumption that you can get away with not understanding the underlying system. Those are the things that don't survive contact with reality. At the end of the day, you realize Kubernetes is less like a perfect black box and more like a collection of trade-offs. And look, understanding this doesn't make Kubernetes a bad tool. Not at all. It just makes our relationship with it more mature, more honest. It's not a magic box that solves everything. It's a powerful, complex system built on a whole series of really smart trade-offs. And our job as engineers is to understand what those trade-offs are. And I think this quote just says it all. It won't feel like a bug. It'll feel like reality catching up. Because the next time you hit a system limit, and you will, you'll be ready for it. It won't feel like some random, frustrating bug. You'll recognize it for exactly what it is, a natural boundary of the system. A sign that it's time for your architecture to grow up. It's just reality, finally catching up with the magic. This whole story is such a powerful reminder, isn't it? Every single complex tool we use, every platform, has these hidden truths and trade-offs buried inside, which really leaves us with one final big question to think about. What hidden truths are waiting in your own systems? What assumptions are you making, and where is reality just waiting to catch up?